chat a bit about optioneering and recommendation strategies. So here's a bit of a hierarchy of floor systems, and you have a standard concrete floor slab, in situ poured slab, with about 4% reinforcement. You see the bulk of the impacts there are at the product stage, so manufacture the concrete, well actually the cement within the concrete, it's the cement that forms the bulk of the impacts rather than the aggregates or the water that goes into it. Yeah, it's the cement, very heavy greenhouse gas emissions coming up from the cement manufacturing process. There's a bit of end-of-life impacts, what happens when the concrete ends up in landfill, and quite a bit of transport impacts as well. They're very heavy materials, cement and aggregates, so transporting them around can be quite significant. So strategies to improve that, we can think about swapping like for like systems out. So in this case, you've got a bubble deck or waffle pod. If anybody is not familiar with those kind of systems, let me just pull that up here. It's basically creating holes or hollows in the concrete. In this one, you've got plastic balls, and the concrete gets poured around these plastic balls, and it means you need less concrete. Plastic balls are empty; they're just filling up a space, but structurally they can perform very well and require less cement, less concrete to provide the same function in terms of slab. Waffle pad, kind of similar. What did I say? Is it waffle pad? Yeah, waffle pod, sorry. Yeah, you've got these kind of plastic tank type things where you essentially, yeah, you have this grid of reinforcement and steel, bit of plastic or hollow plastic, and cement or precast concrete formed around it. So that's quite effective, but savings tend to be not that great. Not bad, better than the original, but fairly minor. We're still massively unsustainable in that sense, or huge impacts from the cement there. Other things like blast furnace slag, which is a waste product that comes from the a blast furnace in a steel mill. So there are two ways to manufacture steel. There's an electric arc furnace and there is a blast furnace. Electric arc furnace is a lot more efficient and what will typically be used for recycled steel products and reinforcement. So many steel products can only be made in electric arc furnace. Blast furnace slag, blast furnace steel is a little bit of an older manufacturing technique, but still widely used across much of the steel industry. And it has this waste product with this slag that is basically a powder that can be used in aggregate replacement, cement replacement as well. You can get up to 40% replacement of cement using blast furnace slag, and it could be a direct replacement really. It's often you know, it's a waste product, so or almost a waste product, so it can be sourced very cheaply. You really just have to pay for the transport impacts to the transport to get it to the site or the cement manufacturing plant, and it will yeah, directly replace the cement. When you increase it by above 30–40%, you can get mixes of 50, 60, even 70% BFS, but it requires a bit more thought. You may need to put some additives into the concrete to ensure it's meeting the same specifications in terms of structural integrity and more importantly, the setting time. Blast furnace slags, concrete mixes are actually tend to be stronger than cement concrete mixes, but they do take longer to set. And yeah, if that's critical for the project's scheduling, etc., then they need to put in additives, and the cost of that needs to be factored in. But yeah, you can get up to a 40% like-for-like replacement, and even bigger if you design in from an early stage that you're going for a higher slag content. Fly ash, very similar, considered more of a waste product than blast furnace slag, and so you get slightly bigger savings, but very similar in terms of its makeup. It's sort of powdered material that can replace cement like for like. The sources of fly, there's still reasonable sources of fly ash or stockpiles of fly ash in the UK. Fly ash is a waste product from coal-fired power stations. Obviously, none of those operating anymore. Or I don't know, is there still one out there? I think they're all being shut down, or certainly will be in the next couple of years. And but there are stockpiles of this waste product in or very near to those shut down power stations. There's also a lot of countries that are still burning a lot of coal and have a lot of fly ash availability. Germany, not very far away, has a lot of fly ash. One interesting piece of analysis that you can run in the LCA is to test the transport distance that your fly ash is coming from. If the design team or the concrete supplier saying that we can't get fly ash from Germany or Europe or the UK, but we do have some available that's being shipped over from China, you can plug that transport distance into eTool and test if that's going to be a sustainable solution or an improvement, or is actually going to increase the efficiency. I'd say if it's being shipped, it's probably still a good option because shipping impacts are really very small. But if it's coming over land from China, then by truck or train, then yeah, it's probably borderline whether that's a go or not, and you're better off with just normal cement. Steel obviously is another floor structure, and it tends to come in very similar in terms of impacts to concrete. So I haven't plugged it into this graph here, but yeah, your only option there really is to be looking at recycled content of steel and trying to make structural efficiencies in terms of the loadings that it needs, and reducing the actual quantity of steel needed. Then we get to timber, which is basically almost carbon neutral, and yeah, CLT, glulam timber products forming the structure is by far and away the biggest saving, the most beneficial strategy that you can put forward and the design team can go for. You've got the sequestration of the carbon that when you grow the trees, they sequester the carbon out of the atmosphere. You're creating demand for these trees, so you get a credit for that sequestration at the product stage. And so that's a negative value. Now, when the building gets demolished, there may be end-of-life impacts. The studies on this are quite interesting. A lot of people are finding that actually timber just sits there in landfill and doesn't really emit very much. But worst case scenario is that it's as impactful as the emissions that it's sequestered, and so you have a carbon neutral outcome in the end. obviously these could also be carbon neutral by UK DBC definition if you buy offsets, pays for somebody else to grow timber somewhere. But yeah, 40,000 kilograms, 40 tons there, 40 times 100 pounds. That's going to add up on the building scale. Sorry, I've just seen question. Oh no, no questions. Okay, good. Yeah, anybody that does have questions, please do get in touch on the chat box there. But yeah, so timber, there's often sort of small things that we can do to material choices and sort of play around the edges with them somewhat. But really, if we're looking at really going for it and producing a sustainable carbon neutral building, then we want to be pushing timber wherever possible. It's got that double win of having very low impacts to create timber products, in terms of the forestry and manufacturing processes. You got the glues in the CLT, which can be quite significant, but when you factor that in against the sequestration, you just get this massive saving every time. So with walls, the similar story is the hierarchy. You've got your kind of concrete block walls, worst case, but probably one of the strongest structurally, I guess. Then clay bricks come in slightly better in meter square basis compared to your concrete block. You get aerated concrete blocks, which come in a little bit better. Then recycled bricks. Steel stud plasterboard is an improvement against brickwork or blockwork. Then you got your kind of natural materials, mud bricks or rammed earth, small scale residential stuff, but quite challenging on a larger scale because they're structurally not so well performing. But again, CLT or timber structured walls get that sequestration credit and have almost a carbon neutral or net zero outcome for your walls. What else have I got here? Cladding. So we have hierarchy here of different cladding options. Things like your granite, your copper, any metal that's going on the side of a building, it will have very big impacts. Aluminium sheets, copper sheets, steel sheets. So steel slightly better than aluminium if you're looking for a kind of like for like swap. Avoid copper, that's one of the worst ones, and granite quite heavy impacts as well. Then these other items, your fiber cement, glass reinforced panels, timber weatherboarding, PVC weatherboarding, they're all very low impact compared to the metals. So yeah, try and avoid the metals. If they do require metals for their design, then I guess it's steel. But yeah, try and avoid and push them towards GLP, fiber cement, or timber, obviously, if they can. Timber weathers very differently. Still lasts a very long time, maybe not as long as metal sheets, but still lasts quite a long time. It weathers quite differently. Obviously, there'll be a cost for replacing those timber boards over time that needs to be factored in. But yeah, you've got that carbon neutral outcome. If you're thinking about net zero, true net zero, and the cost of offsetting these other items, then you're still, even with replacing your timber 2 or 3 times over a building's life cycle, still going to be cheaper than paying for the offsets of the copper sheet that lasts for the entire building's life cycle. Okay, yeah, I thought those are a couple of key ones that I wanted to look at in detail. What we'll do is jump into the software now, just run through how we run recommendations in eTool. And then for the last 20 minutes, half an hour, open it up. Anybody has any questions or anything that they've been struggling with lately in the tool. Anything around BREEAM reporting, LCA reporting, whatever you want to chat about. Yeah, we'll open it up. So I'm just going to pull up this example that we did for training the other day. And we've got a LCA model here. Not sure how complete it is, but good enough for the example today to run some recommendations. It's made up from 10, 15 templates here. Foundation system, pile caps, upper floor slab, is a profiled concrete slab on a metal deck, ground floor slab, got some excavation in there. This is a steel building, so lots of structural steel, tonnage figure. Their frame structure, roof system is concrete deck, staircase. External walls are aerated blocks, commercial aluminium double glazed windows. They're quite significant in terms of their impacts. Doors, internal wall systems, and a small bit of landscaping there. Yeah, there is a whole credit for landscaping in BREEAM 2018, even though it tends to be pretty minor in terms of its impact. So that's my model, my base model. The process now is that we want to run some strategies, some options, and understand what the benefits they're going to provide in terms of carbon or LCA performance, and which ones we can prioritize or try and implement with the design team. So I go here, clone, and I call it maybe improved design. Clone there. And we have this recommendations tab, so working from there, and we want to add a new recommendation. And we have templates for recommendations. And here we have, I'll just show you actually, in the eTool libraries, we have libraries for templates for the, all the different construction makeups that might be applicable for a building. And we have a library of EPDs, so individual product LCAs. If you're going to that level of detail, you can swap out generic material data, say for carpets or installation, whatever it might be, and put in the actual manufacturer's LCA data if it's available, either from the manufacturer or we've got quite a few here that we've added ourselves from manufacturers as well. We have a benchmark library where we store our benchmarks to compare building types against, and here's the recommendations library. In the recommendations library, we have all the different strategies that eTool or our users have ever run on their buildings. So quite an effective library. Every time anybody runs a new recommendation or finds something innovative that hasn't come up before, they add a recommendation to their model, and they make it public. And yeah, so if we're looking for materials strategies, we see a big library. These are energy efficiency ones, so monitoring and water systems, energy efficiency, renewables, etc. Functional recommendations, which are quite interesting. Things like, okay, the current design life of this fit out is 20 years, but if we can persuade the tenant to stay there for 40 years and keep more or less the same stuff other than general maintenance, then you've already effectively halved the impacts of that fit out. So increasing design life, increasing occupancy, increase the number of people using a structure, then you can get some much bigger wins environmentally than going straight into detailed sort of swaps of materials. These are all sort of early brief stage, I guess, strategies, but useful to be aware of and consider. And yeah, if you are lucky enough to get on that early in the day, then maybe something clients can factor into their brief and the resulting designs as well. So yeah, reducing car park spaces, being efficient with that space. Again, all about getting most efficiency from the use of your materials. Then we've got all these material recommendations. I won't go through them all, but they're all there for people to use and adapt and run on their designs. Material swaps, replacements, that's concrete. Construction waste is quite an interesting one. Each material in eTool, just show you that. So here's profile steel in a concrete deck, and it has 1% by default average construction waste, so you'll use about 1% of this during construction to waste. Every material has different waste factors that get applied to it. And if you've got a waste target, say you want to reduce you reduce your waste by 25% or 50%, you can update these figures, put 0.5 in there, or you can use bulk swap and have a blanket. We don't want any material to have more than 0.5% waste or yeah, whatever the target might be. So yeah, that's quite an interesting one, and obviously provides some good environmental benefits as well. Coverings, yeah, it's material swaps. This one's quite important for services analysis. By far the biggest impact from services items. Yeah, they use a lot of metals and components and manufacturing processes, but by far the biggest impact is the refrigerant gas and the leakage of the gas. And so alternative refrigerant gases or leak detection, things like that, really useful recommendation to look at. That's what I was talking about earlier about the manufacturing process of steel. If you source your steel from an electric arc furnace, it'll probably have, well, yeah, it will always certainly have lower impacts than blast furnace steel. At tender stage, we might not want to go into the specifics of, you need to use only Tata steel that has an EPD. That's quite specific, but if you say, okay, we'd want all the steel to come from electric arc furnace, it's going to also present a benefit to the project, and yeah, it gives more flexibility from the supply chain to source competitive materials. Modular building, again, looking at waste probably, and reductions in trade staff impacts and their transport distance. Interlocking bricks, recycled content of materials. So some materials have different options for the recycled content. carpet in particular, there's quite a few options in eTool for different carpet types, and that's dealing with recycled content. Asphalt quite heavy in terms of impact, so non-asphalt alternatives. Should say, yeah, each of these recommendations has a bit of blurb, a little bit of information about what they mean, what you might be considering. This one's looking at alternatives such as brick, concrete, granite paving, lasts a lot longer and has lower impacts. Also looking at permeable paving there, and sometimes some pictures. And when you run the recommendation in your model, this text feeds through to your final LCA report, and you can update it as well. You know, you can write in here, the design team considered this and what they thought about it, or any other design implications that you as a consultant might want to document. Then yeah, you can edit that in the recommendation field. Let's just go to the bottom of these material ones. So lots of replacements here. Again, yeah, generally looking at trying to get some timber in there somehow. So timber framing, plastic panels. So plastic roof panels, quite common in roof lights and atriums and things. Plastic, way better environmentally than glass. Absolutely, hands down. Glass, very intensive to manufacture. Plastic, relatively low impact. And so plastic glazing and plastic panels are generally a lot better than glass. Timber window frames, timber concrete blocks. Solar screen, looking at the difference between a glass solar screen and a metal mesh type solar screen. Intermittent paint, so you'll find with any larger project where it's got a lot of structural steel in it, there's a lot of intermittent paint that's used on the steel. And that gets replaced fairly regularly, repainted very often. How does that compare to fire protection board? Quite an important one to make sure you factor it into your model if you're doing quite common at stage 2 to look at the difference between a steel structure and a concrete structure. Make sure you're including the intermittent paint in your steel structure option, because yeah, it can add up and be quite significant impact. And you know, the difference between concrete and steel can be quite close anyway, so don't forget to include the paint. And if they do go down the steel route, then what are alternatives? Can we get paint that lasts longer, has an extended warranty, or looking at fire protection boards instead of paint, a bit more intensive to install, but yeah, potentially lower impacts. Alternative installations, looking again at timber or OSB in place of plasterboard. Precast slabs for in situ concrete, probably fairly similar because they're both concrete at the end of the day, but yeah, it's something that our users have done in the past. This one's more around finishes, so raised access flooring for plastic flooring. There's a lot of impacts from fit outs over a building's life cycle. Every 15 years, you're ripping up the raised access floor and replacing it with another raised access floor. And that's massively wasteful. But there are alternatives, like if you do have to go down that route, try and go for plastic raised access floor systems rather than steel ones, and you'll get some good savings there. Or reused steel raised access flooring. Again, plastic ductwork in place of steel. I've also seen paper cardboard ductwork that's come available recently, which looks quite interesting, probably very cheap, may not last forever, but looks like a really interesting solution and will be very low impact as well. Oh yeah, there it is, plastic cardboard. See if there's a picture of that one in there, because it's quite an interesting one. Timber stud in place of steel stud. Retaining existing items, and see if you can reuse what's already on site, then you don't have to factor the impacts of that into the LCA. That's already been accounted for in the previous buildings. LCA, you don't want to double count it, so effectively for reused items, you can they have zero or net zero impacts. Extending the lifespan of materials, extending their warranties. SIP panels. Reducing transport distances, steel and aggregates, your big transport hitters. And when you run your top impacts report in eTool, you can see which impacts have the highest transport, which materials have the highest transport impacts. Normally it's steel, aggregate, and concrete. And yeah, reducing those by 50% or whatever it might be can give good savings there. Unitized window frames in place of curtain walling or whatever the baseline might be there. What was that one that I was looking for? So that's your plastic ductwork. Yeah, there's not a picture of it. Let me just see if there is online somewhere. That looks like something. Yeah, here it is here. So yeah, large cardboard ducting type systems. Difficult ones with anyone who's not looking for innovation, because when you look at some pictures like that, they look quite flimsy. But there are products that are solid and well manufactured, and yeah, made from cardboard. So quite interesting one. Good. Okay. Yeah, that's all the materials recommendations. I'm just going to run one quickly in eTool. It's always important. You can. Some users jump in and they'll run an option in the model, not using the recommendations tab. They'll just go straight in and start making changes. Option 1 in this model, and start deleting materials or templates, making updates to the model. We encourage you to always use the recommendations functionality when you're recording options, because it gives that log of what you've done. You can yeah, make notes of it in the tab here, so when you come back to the model, or when somebody comes and reviews your model, they'll have a clear picture of the changes that you've made and the options that you've run. So let's look for materials one. And we saw our glazing was quite big, so let's swap timber frame for glazing. What you do is you go to add and record. Software is now taking a picture of all the impacts, whether it's CO2 or cost or acidification or any of the other environmental indicators. It's got that all saved, and it will measure the difference, the delta between what was there previously and the changes that we make now. In this case, I'm going to take my windows here, double glazed aluminium windows. I'm going to copy the quantity, delete that template out, and add a new one. And this one was, we could add a timber hybrid, which is maybe more, gets a better response from design teams than all out timber. But let's start with the best case, and we'll work backwards. if we see resistance to going for full timber. So I'll plug in the same quantity, save that. If you remember, there was quite a big bar where the windows were. Now that's much smaller. We go in here. We see actually most of the impacts are in the installation. Crane to install and replace these windows every 40 years. Something that worries a lot of the LCA practitioners is glazing and cladding on these large buildings. What's going to happen in 30, 40 years time when the glazing's completely non-functional, leaking all over the place and needs replacing. That's a massive cost for the building owner and a massive disruption probably as well to the building. How you do that for something like the Shard, I don't think anybody's actually really considered what they're going to do in 40 years time, but yeah, it's significant. And strategy actually that didn't see here is materials efficiency and actually reducing those impacts by reducing the glazed area. Your concrete blocks or your structure will last forever. Reduce the glazed area and you have all kinds of benefits in terms of carbon, embodied carbon, life cycle cost, maintenance, your energy savings, your thermal efficiency. Yeah, get them back down to optimum rather than the fully glazed fashion that's hugely expensive, both in terms of capital and ongoing maintenance cost in a few years' time. Well, and every year in terms of cleaning those windows as well. Anyway, yeah, so I stopped recording there. And I save that. And here we see the saving here. So you have an initial saving in carbon terms because, yeah, timber much better than aluminium. But that saving also increases every time you replace those aluminiums every 40 years, the life expectancy of the windows, you replace them. You always assume in LCA that we replace like for like. So in 40 years time, we replace the timber windows with timber windows again, and you get that saving again. And yeah, so quite a healthy benefit there, 4,000 odd tons of CO2 saved. Just so you know, this building has a life expectancy in this case of 200 years, and these windows were replaced every 40 years, so 200 over 40. You see how the savings can rack up over time. Some strategies, if you're replacing structural items that are going to last the full 200 years, then you would just see an initial saving and nothing else change over the life cycle. But wherever an item's replaced, you see those savings increase each time they get replaced. Looking at CO2 savings, jump into ozone, and we see that there's actually a slight increase in ozone impacts compared to aluminium. Let's see what the cost is looking like. Slight increase in cost there as well. 89 million, and yeah, fairly significant increase in costs actually. Timber windows are more expensive than aluminium generally, and will be over time. But start to factor in the price of carbon, which is being talked about more and more at the moment, and we might see some really interesting results there. Okay, I've waffled on quite a bit. 10